Hello grade 11s and grade 12s. In today's video, we will be looking at an exam question, a past paper question based on Newton's second law and using simultaneous equations. You can see the question on the screen. Let's read it and let's get on with the question. But before we do that, I just want to remind you to stay tuned throughout the entire video because I give a lot of teacher tips as I go through the questions. I show you where you get your marks, where learners often make mistakes, and where you can avoid making mistakes so that you can get the best possible marks. Right, so this question says in the diagram below, so they give me a diagram, we've got an 8 kilogram box, and you can see that that is on a flat horizontal surface, and it's connected to a 4 kilogram block that's over here by a light inextensible string. Now, what they don't mention in the story, but what we can see on the picture is the fact that the 4 kilogram block is on an inclined plane. This is an interesting question. It's not a very common question. You might be more used to seeing questions that look something like this, which I will be doing in a different video. Remember to check out the playlist linked below for more Newton's Law videos and to subscribe for more of this types of questions. But what I'm trying to say is this looks different. So they are connected, and it says here by means of a light inextensible string. And we should know that when two objects are connected, first things first, there will be a tension force in this rope. A tension force in this rope. They say that there's a constant force of 55 Newton applied to the 8 kilogram block to accelerate, there's a keyword, accelerate the combination of blocks to the right. So this is our force applied of 55 Newton acting to the right. They are telling me that the combination is accelerating to the right. So this 8 kilogram block is accelerating to the right. This 4 kilogram block is accelerating up the slope and to the right. Very important things are being said at the moment. First of all, as soon as we see the word accelerate, we know we're dealing with a Newton's second law question. And this is just emphasized or backed up by the fact that they asked me to state Newton's second law of motion. And we should know that Newton's second law, we always start off with F net is equal to mass times acceleration. The net force is equal to the mass times acceleration. I will be using that in the question. I will be starting off with that. The other thing that I want to mention is that because these objects are connected, they will both accelerate with the same acceleration or the same magnitude of acceleration. Okay, magnitude of acceleration will be the same. So the value for A will be the same for both blocks, and the tension in the ropes here will be the same for both blocks. Just bear in mind, and we'll discuss this when we do free body diagrams, but the tension in this rope over here is pulling the 4 kilogram up and to the right, but the tension in this rope is actually pulling the 8 kilograms to the left. And that is confusing for some students. Remember, the applied force is pulling the 8 kilograms to the right, but the tension in the rope is pulling the 8 kilograms to the left slightly. Okay, right. They also tell me about kinetic friction that's acting between the 4 kilogram block and the inclined plane, and the kinetic friction between the 8 kilogram block and the horizontal plane. Great stuff. We have all our information. Let's get the definition out the way first. Definitions worth 2 marks. In grade 11s and grade 12s, it's very important that you state the definition correctly according to the exam guidelines. You can find the exam guidelines online. Just type in physical sciences exam guidelines grade 12. In grade 11s, these exam guidelines apply to you as well because you learn about Newton's laws in grade 11 and you're tested on it in grade 11, but you're tested on it again in grade 12. So this is the definition of Newton's second law. I've written it exactly as it is in the exam guideline. And I've highlighted some important keywords that if you leave out these keywords, you get minus marks. So you have to say a non-zero resultant force. When a non-zero net force, either non-zero resultant or non-zero net, you can choose between those two words, but everything else you must say just like it is in the definition. You can't take shortcuts and say F net equals MA or explain this in a shortened version. You will lose marks. Okay, our next question says, draw a free body diagram of all the forces acting on the 4 kilogram block. And I've mentioned this in other videos as well. If you struggle with drawing free body diagrams, I have a whole video dedicated to it, linked in the description box below. But I have mentioned that if a free body diagram is with 4 marks, we need to see 4 arrows. And we're doing it for the 4 kilogram block. Now, I know the question asked me for the free body diagram for the 4 kilogram block, but I encourage you, so that's the answer to 4.2, I encourage you to do the free body diagram for both of them, just so that we can use them to help us with our next question. But 4.2 asked me for the free body diagram of the 4 kilogram block. So I draw the object as a dot. I'm making my dot quite big. I always do that. Now take note how the 4 kilogram block is on a slope. So what I tell my students, because it helps sometimes when drawing free body diagrams on a slope, draw the slope in pencil. The weight always acts straight down. So your weight, Fg or W, always acts straight down. The normal force is always 90 degrees or perpendicular to the surface. So you can see over here, my 4 kilogram is on a surface. The normal force must be 90 degrees to the surface. So I need to draw this Fn, the normal force arrow, Fn or N. This arrow here must be 90 degrees, more or less. 90 degrees to the surface. That's super, super, super important. So we've got the normal force, we've got Fg. Then remember, the block is accelerating upwards, up and to the right like that. So because the block is accelerating upwards like that, the box or the block is moving up and to the right. Friction is going down and to the left. And you see how I make it along the slope, parallel to the slope. That's Fk or kinetic friction. Then, how is this block moving up the slope? There's a tension force pulling it up and to the right. Now, tension is also parallel to the slope. So I hope you can see, I'm going to call it Ft, tension. I hope you can see that the tension force and the frictional force are both in the same plane. They are both parallel to the slope. Then you can erase the slope once you are done. Now that is the free body diagram that you will draw for marks. You will get a mark for your normal force, tension, Fg, and friction. Do not add any extra forces and do not resolve the forces into components on this diagram. So what I mean by that is we all know that Fg, because the box is on a slope or the object is traveling up at an angle, it's not along a horizontal flat surface like the 8 kilogram block. We know that Fg can be broken down into components. Fg perpendicular and this one over here, Fg parallel. But we must not include that on our free body diagram that I am submitting for marks. This is how your free body diagram must look. However, I always tell my students that in order to tackle the next question wants me to calculate tension. In order to tackle the next question, I need to calculate tension, which is one of my forces. In order to calculate tension, I need to know all the forces acting on this block in this direction, because tension is acting in that direction. And to help me with that, it does help to redraw your free body diagram, a rough version to be used in my calculations. So in 4.3, I'm going to perform some calculations, but I'm going to redraw my free body diagram just so that I can use it in my calculations. It's like a rough version. So I've redrawn my free body diagram. Remember, this one over here had 4 marks, 4 arrows, but this one over here is for my 4 kilogram block, but it's a rough version. So what I can do on this now is, because the block is traveling at an angle, so because it's on a slope, you just need to know if an object is on a slope or an incline, I need to break weight up into its components in order to use the components in calculations. So we have Fg perpendicular, which is this one over here, and Fg parallel. The angle between these two is always 90, and because the angle of the slope is 30, the 30 degrees goes here. I did an entire video on how to do this and how to know how to break it up into components. So if you've missed that, and if you don't understand how what I did here, please go look in my playlist linked below. But a nice thing to remember is that the normal force and Fg perpendicular are always in the same straight line. You can see them like that. And Fg parallel is parallel to the slope. So if tension and friction are parallel to the slope, Fg parallel is also parallel to the slope and therefore parallel to these forces. And the angle always goes between Fg and Fg perpendicular. Always. Okay, so this is the free body diagram of the 4 kilogram that I'm going to use to help me in my next question. And although the question paper didn't ask for it, I'm going to do a free body diagram for the 8 kilogram because it's going to help me in my next question. The reason I know that I need both objects in the next question is because they want tension. Okay, they say calculate the tension. I'm looking for T or FT. It's 6 marks. As soon as you see 6 marks and they're looking for tension or acceleration, you should know you are most likely going to do a simultaneous equation problem. And the other reason I know I'm going to do simultaneous is because I do not know what tension is. Think about your free body diagram. If you think about all the forces acting in this direction, the parallel direction, because remember the box is accelerating in the parallel direction. I don't know tension, I know friction, I can work out FG parallel, but I also don't know acceleration. So basically what I'm trying to say is we have 2 unknowns here. Acceleration is unknown and tension is unknown. And the only way we can deal with 2 unknowns is if we do simultaneous equations. And the only way I'm going to do simultaneous equations is if I have 2 equations. You should know that in order to do simultaneous equations, we need 2 equations. How am I going to get 2 equations? I need to use 2 objects. And I use the free body diagrams for each object to help me get the equations. Okay, so this is the free body diagram for the 4 kilogram object. How do I do a free body diagram for this object over here? Well, this one's a bit easier. It's on a flat surface. So I've got FG acting straight down. FG, gravity, or you can say W, it doesn't matter. We've got the normal force acting straight up, Fn. We've got an applied force pulling the box to the right. That is F applied. That's the 55 Newton. There we go. And then, very, very important, make your dot nice and fat. Okay, the reason why is because there are 2 forces acting to the left for the 8 kilogram block. I hope you can see what those forces are. The 2 forces acting to the left for the 8 kilogram block are friction. Why? Because the block moves to the right, friction always acts in the opposite direction of motion, and we have tension, Ft. Remember we discussed earlier how although the box is being pulled by an applied force to the right, it's connected by a string to this other box. And that string is kind of tugging the 8 kilogram box to the left a little bit. You know, it's like dragging it back a little bit. That's why tension is to the left. Ft for tension. Now, what I'm going to do is the following in order to find tension. Tension exists over here and tension exists over here. So this is a big hint that we're going to use simultaneous equations. What we need to do is, because let's look at the 8 kilogram block first. Because I'm looking for tension, and tension is a horizontal force. It's going like this way, left, right. It's going in the X direction or along the X axis or horizontally. I need to consider all the forces going in the left, right direction or the X direction. So for the 8 kilogram block, it's F applied, Fk and Ft. All those forces are acting in this direction, the X direction. Fn and Fg are acting up, down. We don't care about them in this question because I'm looking for tension. Okay, I'm looking for tension. And I also don't know acceleration. And acceleration is also, the block is accelerating left, right. What about for the 4 kilogram block? This is a bit trickier for people. The tension is going like this in the parallel direction to the slope. Remember, if I had to draw the slope in, the slope would go like this, like that. So I care about all the forces acting up, down the slope like this. So clearly the forces that I care about are tension, friction, and I hope you have not forgotten about Fg parallel. Fg parallel also acts up, down. It's also parallel. Another thing that my students also get confused about, and I hope that this helps you a little bit if you get confused about it, is they don't know which way Fg parallel is acting. So we know that Fg is straight down, right? And we know that we can break down Fg into Fg perpendicular and Fg parallel. How do I know that Fg parallel is going down the slope? Think about it. If this box had to free fall, not free fall, but free slide down the slope, which way would it move? If I let it slide, it would slide down the slope. That's because the weight or the parallel component of the weight is pulling it down the slope. Okay, cool. Now that I have my free body diagram and I've highlighted the forces that I care about, Now I'm going to set up two equations. Why two equations? Because I have two unknowns and I'm looking for tension and I have two objects, right? So I'm going to use my free body diagrams to help me set up those equations. Let's set up the equation for the 4 kilogram block first. So I'm going to write here 4 kilogram. We always start off with F net is equal to ma because it's a Newton's second law question. Now, let's first add up all the forces. We have to do a vector sum or vector addition of the forces. So which forces do I care about? We don't need to think about it because I've already highlighted them. I care about tension, FG parallel, and friction. Remember, you can call this W parallel, weight parallel. It's the same thing as FG parallel, is equal to MA. Right. Now, let's set up an equation. I know I haven't finished this. I must still substitute in my values, but I just want us to get the equations quickly. Let's set up the equation for the 8 kilogram block. Remember, we start off with F net equals MA. Technically, we only need to say F net equals MA once. So saying it twice here is a bit of an overkill, but it doesn't matter. Now, let's use our free body diagram for the 8 kilogram to write our sum of our forces. Okay, so I pasted my free body diagram over here. We care about the yellow highlighted ones. So I care about F applied plus tension, and I always do this. I always write my equal sign and I don't have enough space. Plus tension plus friction equals mass times acceleration. Now we need to choose a positive direction because we need to put values in here. Remember, we do not know acceleration. We do not know tension. We have two unknowns, so it's definitely simultaneous. But let's choose a positive direction. I'm going to choose to the right as positive. And because I'm choosing to the right as positive, it makes sense to choose up the slope as positive as well. So if you've missed my previous simultaneous equation video, I mentioned that this is one continuous flow of motion. So up the slope and to the right must be positive. Right. So do you agree that for the 4 kilogram block, focus on the 4 kilogram block, tension is going up the slope. So it will be a positive. FG parallel is going down the slope. So it will be a negative. And how do we work out FG parallel? I've done this in a previous video, but it's mass times gravity times sine of my angle. Mass times gravity times sine of my angle. Sine because I'm looking for opposite. So the mass of my 4 kilogram block is obviously 4 kilograms. That's the mass. G is gravitational acceleration, 9.8. And sine of my angle, sine and my angle of my slope is 30. So I just wrote the formula there because remember, you always need to write your formulas. Mass times gravity sine 30. It's negative because FG parallel is going down the slope. Then friction is also going down the slope. So it's also minus. And do you recall that they gave me friction in the question? The kinetic frictional force between the 4 kilogram block and the inclined plane is 4 Newton. They gave it to me. So it's minus 4 equals the mass of the block is 4 and we've got acceleration. I'm going to simplify this equation over here. So I'm just going to put these two terms together because I can simplify it. There we go, I've simplified it, and that is my first equation. Then let's do the 8 kilogram block. Now remember, we took right as positive. F applied is 55, positive because it's going to the right. Tension, I do not know. However, tension is going to the left, so I'm going to substitute it in as minus Ft. Friction is also going to the left, so I'm going to substitute it in as minus, and they gave it to me in the question. Let's go back and check. Remember, they said kinetic frictional force between the 8 kilogram block and this horizontal plane is 8 Newton, so it's going to be minus 8. The mass of this block is 8, and I don't know the acceleration. So if I have to simplify that, I'm going to get 47 minus Ft 8a. And that is my second equation. Now, you all know simultaneous, I hope. We have two unknowns, Ft and acceleration, Ft and acceleration. The question wants me to find the tension in the string. So if we do elimination like I taught you in the previous video, we can do that. Remember, we add equation 1 and equation 2. However, you'll see what the issue is, not the issue, but it's a little bit of a long way with doing that. We add these two together, which is perfect. It's fine. We can do it. Remember, when we add them together, 4a plus 8a is 12a. Then be careful because we've got positive tension plus minus tension. Those cancel. And then we've got negative 23, 6 plus 47. And we've got 23, 4. If I solve for that, I am going to get a value for acceleration. I get 1,95 meters per second, which is fine. It's just that I don't want acceleration, I want tension. Then to get tension, we need to sub acceleration into either of the equations. So let's say equation 1. So here's equation 1 over here. We rewrite it. Ft minus 23, 6 equals 4a. In the place of a, I'm going to put 1,95. And then when we do that, we can solve for tension. So what we do is we multiply by 4, then we take over the negative 23.6 and we add 23.6, and we should get tension as being 31,40 Newton. Just be careful. They want tension in the string connecting the block, so you should give a direction. You should say to the left for the 8 kilogram block, because the tension, remember, acts to the left for the 8 kilogram block, and it acts over here, it acts up the slope for the 4 kilogram block. So because they just want tension, they didn't say magnitude, you need to give direction. So using elimination, that's one of the ways in order to solve the simultaneous equation. However, another way we can do it is by using substitution. So remember, when you do substitution, you take one of your equations. So I took the first equation and I made tension the subject of the formula. I did the inverse operation for minus 23.6, which is plus 23.6. You took that over, remember, to get tension by itself. And we created a new version of formula number 1. Then what we're going to do is we're going to sub number 1 into number 2. So what number 1 says is it says tension is equal to all of this. So in the place of tension, I'm going to put all of that. Just remember to use brackets. So we say 47 minus, remember, minus is from there. In the place of Ft, I'm going to put 4a plus 23.6 equals 8a. And if you do the math over here, you would, or you should, get the same answer if you do it correctly. So just make sure that you are doing things correctly. And you get the same thing, you get 23,4. So then acceleration is the same as we got it when we did elimination, 1,95 meters per second. And then you still have to substitute that into one of the equations. So let's say sub a into equation 1. So you use equation 1, and in the place of a, you put 1,95 and you solve. You will get exactly the same answer as we got when we did the elimination method, which is 31,40 Newton. Just remember to include your direction. I hope this question was helpful. Simultaneous questions is definitely something that you can be asked in Newton's laws. So I hope that practicing all the weird types, so maybe one like this, one where they're on a slope, one where they're on a flat surface and connected to one another. You need to practice all the different types to ensure that you know what you're doing. Remember to check out the playlist linked in the description box below. I have a lot more past paper questions where this one came from. So I hope you subscribe for more videos, and I'll see you very soon in another one. Goodbye, everybody.